Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, we're going to talk about product of primes. What's product mean?
Multiplication.
Yeah, answered the multiplication problem. And then what's a prime number?
A number that cannot be multiplied to get to.
Well, a number, yeah, like by anything except one in itself, yeah. So, here's the deal. Every composite number, which is a number that's not prime, can be written as a product of primes. So for example, 6 is not a prime number, it's a composite number. But you can say 2 times 3. 2 and 3 are both prime numbers, okay? And there's only one combination that works for every composite number. So like, think about 12. Well, that's 4 times 3. Well, 4 is 2 times 2, so 2 times 2 times 3. But you could also say 12 is 2 times 6. Well, 6 is 2 times 3, so it's, again, 2 times 2 times 3. So there's only one combination. You might end up to it in a different way, but you're always going to end up in the same place. All right, so just to review, prime number is a counting number greater than 1 whose only factors are 1 in itself. So 1 is not a prime number.
Mr. Flack.
Yep.
Can I go to the bathroom?
Yep. Okay. So a prime number is a counting number greater than 1, so not 1, whose only factors are 1 in itself. A prime factor is just a factor of a number that's prime. A factor that is prime. So let's just take any number. Let's say 80. Now you can do this, you can probably do these in your head, but there are a lot of numbers to keep track of, so I wouldn't recommend it. So we use this method. This is called the factor tree method. You guys have probably remember doing this. You can use another method. We call it the cake method. But what times what equals 80?
8 times 10.
8 times 10. All right. Now, are 8 and 10 prime numbers? No, so you can break those down even farther. So keep taking it apart. What times what is 8?
4 times 2.
4 times 2. And then you can break down 4 to 2 times 2. What about 10?
5 times 2.
5 times 2, and then that's it, right? So once you get to a prime number, you can circle it, because sometimes it might get hidden up there, stuck up there, and you can't see it. Okay? So once you get to a prime number, circle it. So this is 2 times 2 times 2 times 2 times 5, or 2 to the 4th power times 5. Okay? So those exponents are going to be important when we start getting into algebraic factorization. Okay? So this is all review. You guys good with this? You know, you could do it another way with the cake method. Let's try it with another number. Let's try 147. So I'm going to write it down here because I'm going to use the cake method. So what goes into cake? So the cake method, you can't do 8 times 10. You have to just divide by prime numbers. What prime number goes into 147?
7.
7 does. Let's see, it goes in 21 times. Is 21 prime? No, what goes into 21?
7 and 3.
7 and 3, and then you're done, right? So then 147 is just 3 times 7 squared. So far, so good? Okay. So if I had to see it's really easy to see what these have in common. They don't have anything in common. We can see all their parts, all their factors. and they have no parts in common. So there's no 2's in here, there's no 3's in there, there's no 5's in here, and there's no 7's in there, so they have nothing in common. So there is a term for that. If these two numbers were a fraction, like 80 over 147, then it'd be reduced, right? Because nothing goes into both of them. So those two numbers we call are relatively prime. They're not prime numbers, but when you talk about two numbers are relatively prime if they have no parts in common. Okay? All right. So now here's the algebra-ness of this. So this lesson, we briefly talk about prime numbers. In the next lesson, 34, we're going to talk about greatest common factor. So we kind of saw that when we factored these two, these have really, they don't have a greatest common factor. They don't have any common factors. So the greatest common factor would be what? 1, that's right. Okay, so let's move on to the next part of lesson 33. We're going to talk about unequal statements. This isn't going to take much here. Here's what I mean by that. If I say twice a number is 42 less than negative 102, what is the number? So how do you say this algebraic sentence? How do you say this in algebra? Any thoughts? 2n, okay. So twice a number is 2n. Then what? Equals. All right, so remember that less than means reverse. So you're going to take what's on the right side and put that first. And then you're going to subtract what's on the left side. Okay. And then you could solve this. Blah, blah. So 2n equals a negative plus a negative is still a negative, so negative 144. So, and then you're going to divide by 2, blah, 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 n equals negative 72. All right? Now, Saxon says, well, you could write it like that. Or you could think outside of the box a little bit, and yes?
But if you do negative 72 times negative 72, then it has to be positive multiplied.
But you're not multiplying, you're adding.
Oh, yeah.
Negative.
Like what? Oh.
Yeah, if you were doing negative 72 plus negative 72. But twice a number, what's that?
2.
So see how negative 144 is 42 less than negative.
Yeah, but 2n isn't that multiplication.
Yeah.
So if n times 2 equals 144, then negative 72 times negative 72 just equals positive 100.
No, negative 72 times negative 72 is a really big number.
Oh, wait. Oh, never mind, sorry.
Okay. So, you could say twice a number is 42 less than negative 102. The other way you could say that is you could just say twice a number plus 42 equals negative 102. Okay? If you wanted to think outside of the box a little bit and restructure your sentence, I just think it's easier to just directly translate this sentence. Okay? And the only weird thing about doing that sometimes is that phrase less than. But I think all of us in this room are okay with less than, right? Because that's when we reverse. Okay. So let me try a couple more examples and then we'll move on to lesson 34. Here's example 4. So 5 times a number is 72 greater than the opposite of the number. So see if you can write a phrase and solve it. 5 times a number is 72 greater than the opposite of the number. Did you get an answer? All right, hold on to that. Give people a minute or two more. Five times a number is 72 greater than the opposite of the number. So what equation did you start with? What translation did you get, Ryona?
I got 5n Scotty's dice, but n also equals 72 plus x.
Nice. So yeah, make sure you're just consistent with the letter n or x, it doesn't matter. Nice. 72 greater than the opposite of the number. Now, so remember when we said less than, we had to reverse? I mean, you could still reverse, but addition is commutative. So it doesn't matter what order you add in, but subtraction is not. So that's why you have to make sure you reverse that phrase. But you could technically say 72 greater than the opposite of a number is negative n plus 72. It doesn't matter, you'll get the same answer, okay? All right, so how do we solve this? What's the first step?
Simplify both sides separately.
Okay, and is it simplified?
Yeah.
Yep, so what's the second step? Yeah, so we got everything simplified on one side. The left side, there's no like terms. The right side, there's no like terms. Now we move on to step 2. So we do have variables on both sides. So what do we get? Which one do we get rid of?
Dividing.
Yeah, let's get rid of that by adding n. So 6n equals 72. We don't have to do step 3, right? Because there's no constant on the variable side. So we skip right to step 4, divide by 6. What does n equal? 12, good job. So 5 times the number, 60, is 72 less greater than the opposite of the number. Yep. So 12, yep. 12 plus 72, or negative 12 plus 72 equals 60. That works. All right. Okay, let me do this last problem. This is an important one just because this is what we were talking about. It's another sum problem. So what's sum mean again?
The answer to an addition problem.
Yeah, so that means we're going to add a couple things. All right, so let's do that. So here's what example 5 says. If the sum of twice a number and negative 14 is multiplied by 2, the result is 12 greater than the opposite of the number? So see if you can write an equation that translates this sentence. If the sum of twice a number and negative 14 is multiplied by 2, the result is 12 greater than the opposite of the number. Okay, you got an equation yet? Kind of a weird one. This is probably the most complicated equation we've had so far, or at least the most complicated translation, and maybe equation. So the equation itself is what we talked about on Tuesday. Translation might be tricky. So, what's the sum again?
That's an addition problem.
Yeah, so the sum is an addition problem. And so remember, after the word of is the first thing we're going to add, and then this word and connects it to the second thing that we're going to add. So how do you say twice a number? And how do you say negative 14? Negative 14. All right, now we have this phrase. So that whole sum is multiplied by 2. How do we do that?
Parentheses.
Parentheses, that's right. So if you just put a 2 in front without parentheses, what are you multiplying?
22.
Just 2 times 2n. You're not multiplying by the sum, you're just multiplying by part of the sum. Okay? So make sure you put parentheses in there. So most of the time, well, you might just have the sum of something and something is whatever. But a lot of times you'll see like 5 times the sum of a number and 6 or something. Okay? So when you're multiplying by the sum, you need parentheses. The result is, how do you say that?
Equals.
Okay, and then how do you say 12 greater than the opposite of the number?
12 plus.
Nice. Okay, so this is an equation we learned how to solve on Tuesday. All right, so let's see if you can solve it from here. If you already solved it, great. I want to give you a couple more minutes just in case you had the wrong equation down. So see if you can solve that. All right, so I'm gonna dig in. I'm gonna take out my black marker because I'm gonna do step 1 first. What's the first part of step 1? What do we need to do?
Remove parentheses. We're gonna simplify both sides.
Yep, so the first part of that is removing parentheses. How do we get rid of these blue parentheses? Distribute. So draw your rainbows. Boom, boom. What's 2 times 2n? 2 times 2 is 4, and then tag on that n, so 4n. Plus, what's 2 times negative 14? Negative 28 equals 12 plus negative n. So any like terms on the same side? Nope, so we're done there. Okay. So now move on to step blue. What do we do next? Yep, which one's a smaller variable? How do you get rid of negative n? Add n, good. So 5n plus negative 28 equals 12. Now get rid of the constant on the variable side. How do we get rid of plus negative 28?
You add. It's negative 28, so you add.
Yep. So you could, since it's being added, you could subtract negative 28, but what happens when you subtract a negative? You're adding the positive. So to get rid of stuff, you either do the opposite operation or the same operation with its opposite. Okay, that's a little tongue twister, but I'm going to do the same operation with the opposite of negative 28, which is 28. So 5n equals 40. Last step, divide by variable's coefficient. Did you get 8?
Yes.
Nice. Then just throw it in the sentence, make sure it works. Twice the number in negative 14, so 16 and negative 14 is 2. Is multiplied by 2. 2 times 2 is 4. The result is 12 greater than the opposite of the number. Opposite of 8 is negative 8. So 12 plus negative 8 is 4. It works. Okay. Does that feel all right? All right, well done.